I gave you this die right here, and I told you that you would win if you rolled that die and you obtained a 6. What would you think about your chances of winning?
1 in 6.
Okay, 1 in 6. Tell me what you mean by 1 in 6.
Out of 6 times, I statistically would get it once.
Okay, so if he rolls the die, he would think that about 1 in every 6 times he would win. Do you think that's a game that you would like to play and wager a lot of money on? Probably not. All right, so you would win, he says, 1 in 6 times. What would happen, you think, if I gave you 2 dice? And I told you that you would win if you rolled a 6 on either die. That is, if you roll a 6 on this one, or even both of them. What would you think that would do to your chances of winning? Don't think it would do anything.
You would have 2 out of 12, which is 6.
Okay, so one idea is that you would have 2 out of 12, which is 1/6. Does anybody have a different idea about what it might do to your chances? What? Tell me again.
Double it.
Okay. He says it would double it. Why do you think it would double it?
Probability is 1 out of 12 now. So, 2 out of 12. So that's 1.
Well, we're going around in circles with that, aren't we? All right. Not real sure. Anybody else have a thought on what might happen if you rolled 2 of them instead of just 1 of them? Would it help your chances? Would it stay the same?
It's independent.
Say again?
Independent.
Ooh, she used a fancy word, independent. Raise your hand if you've heard the word independent with regard to a math problem before. Independent? If you have. That's a word we're going to use later on today. All right. So I want to propose to you a problem that actually came from a mathematician called Pascal. And the problem was this. If I were to roll 4 dice, what would be the chance that on one of those dice, at least one, I would get a 6? If I rolled 4 dice, what's the probability that on at least one of those dice, maybe all of them, I'd get a 6? Now what I want you to do, there maybe in the corner of your paper, I'd like for you just to make a guess. What probability, what percentage if you want to use a percent, what fraction if you want to use a fraction, do you think would represent the probability or the likelihood of you getting a 6 as you roll those 4 dice? Just jot something down. Remember, hypothesis is just a guess, and then we'll see what happens with your guess. All right, now I'd like for you to work with the person at your table there. You now have a little cup with 4 dice in it, and I'd like for you to do a little experiment and test your hypothesis. I'm not going to tell you how many times to roll the dice. You come up with a number of your own. You may decide we'll roll it 10 times, we'll roll it 20 times. We'll grab for a calculator and do something else. That's fine. But I want you to conduct a little experiment, and I'm going to come around and watch what you're doing. And why don't we do this? Just on your paper, do something like win or lose. And let's just make some tally marks. And what will cause you to put a mark in the win column? If you got a 6 anywhere, 1 or more 6s. And you'll mark lose if you don't have any 6s at all. All right, start rolling and let's see how close your hypothesis actually is.
When we're tallying, if we have 2 6s, we count as one.
This is one win.
One
That's
win.
right. So you won right there. She's going to just use as much paper as possible as she goes straight down there. That's okay. What was this was your This is your original hypothesis, okay. Okay, very good. Oh, there's a mathematical equation.
There is a
See, you are using really fancy words, permutations, and combinations, now we just got to see if you know what this means. I like the way you wrote that as the ratio instead of fraction. How's your hypothesis look?
Not good.
Not real good. I understand. Okay, so you say you think you should do it 6 times. What many do you think of it 6 times?
And so we actually both go with the same hypothesis.
And what was that?
If you roll 4 dice at one time, the same as
And did that happen?
But we wanted to try it more than once.
Sure. Sure. Because just like if I take a coin and I flip it 10 times, does that mean it's going to be 5 and 5? And so maybe you want to collect a little more data there. How are you turning out? You're winning a lot.
Yeah, we are. That's just,
So what are you thinking about this?
I was thinking about originally this.
Probably typing it in.
Okay.
Before, and so I was thinking of this remaining one. I'm not finding that in the data.
Okay. And do you feel good that you've collected enough data now to know that this isn't right? Have you collected enough data to make a difference?
Three's a magic number, right?
Maybe collect a little more. Collect a little more. And how are you all doing right now? How's your breakdown?
more even than I expected.
More even than you expected, okay? So definitely a long way away from what you had, right? Okay, good. Okay, so you're in the second time. What did you get? You were dead even. It looks like you're getting close there. So if the world were to stop right now, what would you do? So if you just wonder, how do you have the same thing? All right, I'm going to give you about 1 more minute to collect data, and then we're going to pause and chat for a second. See what experiences you've had.
Because you have the possibility of it happening, the probability is not happening.
And I just heard you say significantly high.
So if you, regardless of the numbers, the odds of rolling 4 dice are 50% of data. Whereas when you roll 1 die,
So we need.
although it seems even, and I'm surprised that it's even, it's still substantially higher if you roll multiple dice for 4 die than
It can be there's
I've heard a lot of good words as you all have been
because this would be.
going through your data. I've heard words like permutations and combinations and independent and significant, all words that have mathematical meaning. I want to go to each group and see what data you have, and let's kind of put all of our data together and see what happens. Let's go to our first group here. Just looking at all the data you have, how many wins and losses did you have in total?
10 wins.
14 losses. So 10 wins, 14 losses for them. All right, from our next group.
We had 9 wins and 6 losses.
9 wins and 6 losses.